Today we're going to talk about percent of change. So first off, percent of change is a ratio that compares the change in quantity to the original amount. Okay, and we express it as a percent. So if we think about percent of change, first off, we want to really think about why we use percent of change. Well, one thing that we would use percent of change for is sales of a company. So I'm just going to put that as an example, company sales. So the reason that we use percent of change, not just numbers, is because it's going to be a more accurate representation. So for example, if I said that McDonald's, they increased their earnings by $100,000. Well, McDonald's is a huge company, so $100,000 isn't really that much. But if we were talking about a small local shop, maybe there's one shop in Vernon Hills, and if they increase their sales by $100,000, that's a much bigger impact. So we use percentages so that we can really see how it relates to the specific topic that we're talking about. So finding the percent of change. So step one, we need to find the difference between the two. So I always subtract the bigger minus the smaller. Then I like to set up a proportion. You do not have to. I'm just going to show this way because this is the way that works no matter what. And obviously if you use the equation, that is fine too. But then we use that to solve for the percent of change. And then the last part is we need to state whether it's an increase or decrease. That's really, really important. If you're saying sales are going up, that's different than saying if sales are going down. So let's look at these first two examples. So example one, let's say that the original amount is $56 and the new amount is $63. So when we're setting up a percent of change, your basic proportion should be the change over the original equals what percent out of 100. So this is the basic setup that you should be doing. How much should change so that difference compared to the original equals the percent out of 100. So back to this problem. The original is $56, the new is $63. So we're going to subtract those two. 63 minus 56 gives us a change of 7 out of the original, which was $56. Equals what percent out of 100. Then we can solve that proportion. So I'm going to multiply the two numbers that are opposite each other. 7 times 100 equals 700. And I divide by the number that's opposite the variable. And I get 12.5%. And then remember, in our answer we need to include if it's an increase or decrease. Well, our new amount is bigger, so it was an increase. Let's look at example 2. So our original amount for example 2 is 29. Our new amount is 25. So first thing I'm doing, I'm finding the difference. 29 minus 25 is 4 over our original, which was 29, equals what percent out of 100. So again, I multiply the two numbers that are opposite each other. 4 times 100 equals 400. I divide by the number opposite the variable, so divide that by 29, and I get about 13.8%. This time our new number is smaller, which means it was a decrease. You have to include both the percent and whether it's an increase or decrease. All right, next example. During the 1993 to 1994 school year, there was one computer for every 16 students in U.S. public schools. Now, there was one computer for every 5 5.9 students during the 2003 to 2004 school year. Find the percent of change of students per computer. So first off, we got to identify the numbers that we're talking about. We don't care about the years, really. We're talking about the number of students. So the change in the number of students, 16 minus 5.9 is 10.1, 10 and 1/10. Over the original amount, it started with the original of 16 students equals what percent out of 100? Then, again, we multiply the two numbers that are opposite each other, 10 and 1/10 times 100 divided by the number of students equals, or the number opposite the variable, I should say, equals 63.125. I'm going to round that to about 63.1%. And our original was 16. Our new value was 5.9, so that's less than. It was a decrease. So it's not that the computers decrease, it's that the ratio of computers to student decrease. So that's a good thing, more computers for the students. Then there's one other part of this lesson, which is percent error. So it's very similar. It's a similar setup, but we're looking at how the error was, how far off you were in maybe an estimation. So percent error tells how big your errors are. It's calculated as a percentage of the actual amount. So that is important that you're looking at the actual amount. That's kind of like the original value. That's what's going to go in the bottom of the proportion. So let's look at example 4. Ariana estimates that she spent $230 at the mall. She actually spent $245. Find the percent error and round to the nearest tenth if necessary. So let's identify the numerical values. We've got 230 and we've got 245. So the difference between those two, 230 and 245, is a difference of 15. Then we got to remember we are looking for not the original amount, so not what this first number here, but what she actually spent. Well, what she actually spent was $245. This part right here is where people often mess up with percent error. It's not this number is off the actual amount equals what percent out of 100. Then we're going to multiply the two numbers that are opposite each other. 15 times 100 equals 1,500. Divide by the number opposite the variable, and you get 6.1224, etc. I'm going to round that to about 6 1/10% error. Okay, now I want you to flip it over to the back. Yes, there are two problems on the back here. Two you try problems that I would like you to do. And then get those answers checked.